Hello. Today we are looking at the Richter scale. The Richter scale is a logarithmic scale and it is used to describe earthquakes. Our first bullet point says an increase on 1 on the Richter scale indicates that a quake is 10 times as powerful. We're asked to explain how or why this works. So this tests our understanding of what it means to have a logarithmic scale. So we know that logarithms, and I'm going to abbreviate that just as log, but this would refer to both the common and natural log, are the exponents. So because the Richter scale is a logarithmic scale, an increase of 1 on the Richter scale would mean that the exponent increases by 1. So if the exponent increased by 1, having a common log, which is base 10, 10 to an exponent of 1 equals 10. This 10 is why the power is 10 times more. So to recap, the fact that the Richter scale is a logarithmic scale means that the Richter scale is reporting the exponents, because we understand that logarithms are indeed exponents. So an increase of 1 means that the exponent would be increased by 1. And so the exponent would be on a base 10 for the common log. 10 to the first is 10, which is why the quake would be 10 times more powerful. So let's look at an example. Back on December 16, 1811, there was an earthquake in New Madrid, Missouri, that temporarily reversed the course of the Mississippi River. It was estimated to have a Richter magnitude of 8.8. So because this is on the Richter scale, this 8.8 would be the exponent. More recently, but still a while back, on October 17, 1989, the San Francisco Bay Area experienced a quake that measured 7.1 on the Richter scale. So this is also an exponent because the Richter scale is a logarithmic scale. The question we're asked is how much more powerful was the 1811 quake than the 1989 quake? So first thing I want to do is just figure out how much did the exponents change. So I'll take 8.8 and subtract 7.1, and that gives me a change of 1.7. So this is the change in exponent. Because it is logarithmic, I'm going to use a base of 10 with an exponent of 1.7. And I put that on my calculator, so 10 caret key 1.7, and rounding off, I got 50. So this means that the 1811 quake would be 50 times more powerful. So I'm using that same idea that we explained up here at the first bullet point. When we increase the exponent, that is the exponent on a base of 10, and so an increase of 1 results in 10 times more powerful. Here, an increase of 1.7 results in 50 times more powerful. Our next bullet point says, if an earthquake is 1,000 times as powerful as the 1989 quake occurred, what would its Richter scale reading be? So 1,000 times, I need to know 10 to what power would equal 1,000. We probably know that one without using a calculator. We know that 10 to the first, let me rewrite that, 10 to the first equals 10. we know that 10 squared equals 100. And so we know that 10 cubed is equal to 1,000. So that means that the exponent would be 3. When the exponent changes by 3, the power would change by 1,000. So the 3 is the exponent, and so when I look back at the 1989 quake, the exponent was 7.1. So if I add 3 to that, I come up with a Richter scale reading of 10.1. Our next bullet point asks us about a quake that occurred December 26, 2004. It was 80 times as powerful as the 1989 quake. It struck in the Indian Ocean near Indonesia. You may remember that. It was very devastating. So we are asked here to figure out what the Richter scale reading is based on the fact that it is 80 times as powerful. So this means that we need to know what exponent is going to result in a quake that is 80 times as powerful. In the previous question, we had set up 10 to the x equals 1,000, but now we have 10 to the x equals 80. And when I think through the exponents that I know, I don't know what exponent for 10 will give me 80. So in order to solve that, I will use the inverse property of logarithms. So I will take a logarithm on both sides. So log of 10 to the x power equals log of 80. Because exponential and logarithmic are inverses, this side of my equation cancels, and I'm left with x, which is equal to the log of 80. So I type that on my calculator, log 80, and hit enter, and I come up with an answer of 1.9. Now this works with what we originally said, that logarithms are the exponents. So when I took the logarithm of 80, it gave me the exponent for 10. I can double check that by going to my calculator and typing 10 to the 1.9 power. And now there was some rounding, so it's not exact, but it is approximately 80. So the logarithm gave me the exponent. So the exponent would change by 1.9. The exponent back in 1989 was 7.1. So 7.1 plus 1.9 gives us a Richter scale reading of 9 for that quake that happened in 2004. Throughout working with logarithms, we want to keep this in mind, that the logarithm gives us the exponent. That's what a logarithmic function is. It's a function of exponents. And so throughout this example, because the Richter scale is a logarithmic scale, all of our Richter scale values were dealing with exponents. And so we use those changes with the exponents throughout this problem.